To introduce uncertainty into the duration of project activities, the first step is to define the level of uncertainty associated with each one. In the parameters sheet, different levels of variation can be conveniently established. For example, medium uncertainty levels typically range from a minimum of 15% to a maximum of 25%. This means that when using probability distributions such as the PERT or the triangular, the percentage of variation relatively to the most likely value, the modal point, must be defined. In cell B8, the type of distribution to be used is selected. Thus, variability ranges can be set as a percentage of the estimated duration of each task. For example, if task 13, development, has a most likely duration of 20 days, a variation of -5% on the lower end and plus 10% on the upper end can be assigned, resulting in values between 19 and 22 days depending on the chosen distribution. In cell F15, where the probability distribution function for the duration of task 13 development is generated, we will keep only the PERT probability distribution. When enabling the distribution chart, observe how the distribution looks like while the variability remains low. Now, let's change the variability of this risk to medium. This will adjust the minimum and maximum values of 17 and 25 days respectively, reflecting a 15% variation on the lower side and a 25% variation on the upper side. Notice how, when the chart is regenerated, the probability curve expands. When the Monte Carlo simulation is executed, the randomly generated values for each activity's duration will be aligned with these parameters. If the level of uncertainty changes from low to high, the range of variation will also adjust. For instance, a duration initially set at 20 days could now range between 14 days as a minimum and 30 days as a maximum, reflecting greater uncertainty. Now, we can modify the function to use a triangular distribution instead. When visualizing it, we will see that the shape of the distribution changes, but the parameters for minimum, most likely, and maximum values remain the same. Remember, in the parameters sheet, we can switch between PERT and triangular distributions. Later in this course, we will analyze whether this change affects the final simulation results. Now, let's restore the original function in column F by copying it down from the upper cell. This function includes a few additional elements that we will explore later in the course. To summarize, this approach allows us to model uncertainty more accurately in project planning, activity by activity. The key is to determine based on expert judgment whether each activity inherently has low, medium, or high uncertainty. Of course, these variability levels can be adjusted for each category as needed. Therefore, by incorporating uncertainty into the planning process, this method provides a more realistic foundation for decision making.